back to the channel. So here we are discussing LeetCode Daily problem, which is count symmetric integers. So you're given two positive integers low and high. An integer x consisting of 2 into n digits is symmetric if the sum of n digits of x is equal to the sum of last n digits of x. Numbers with an odd number of digits are never symmetric. So we need to return the number of symmetric integers in the range low to high. So let's first understand what it means by symmetric. So we have an integer x which is consisting of 2 into n digits. 2 into n means first we got that we want even number of digits. If it is odd, then simply skip that. So if our digits is even, what we need to do, we need to check if there are 2 into n digits, then sum of first n digits, which means if we have like digit places of 0, 1, 2, 3. So this first n digits sum should be equal to the last n digit sum. So suppose if my number is here 1240. So if I take sum of these first two digits, that would give me 3, and the last two digits, that would give me 4 plus 0, that is 4. So this is not our symmetric number. So to form this as symmetric integer, let's take this. So 1 plus 2, 3. 3 plus 0 is 3. Hence this number is symmetric. So if this number lies in the range of low to high, then this will be counted as one of the symmetric integer present. So to find the symmetric integer, we got the idea that okay, the first half should be equal to the second half. The sum of first half should be equal to the second half. So if we observe this, we are getting the sum 3. We are also getting the sum 3 from here. So if we do 3 minus 3, that would give us 0, right? So it means when both the sum are equal and I do sum of right minus sum of left or vice versa, this would give me 0 as both the sums are equal. So if this gives me 0, then hence I have got my symmetric integer. So we can define that this condition satisfied our symmetricity. So to achieve this, what we will do now, just simply we will start traversing from low to high. So once we go from low to high, we go from low to high here. So we will check if our number is even or not. First of all, check that. If the number is even, if my number, that is let's say I, is even, it means this is even. If this is even, then we would check that first we will convert this string so that we can easily check for this. And then for j from 0 to n by 2. N by 2 is the length of the string, this string. So we have converted to string for easy check so that we can divide it into two halves easily and get the length. So in n is my s dot length, and then we check from 0 to n by 2. Once we check this, In this case, if my now we need to convert our first element and the last element. We want sum of right minus sum of left equal to 0. So what we will do, we will add in the sum of the left side elements. Sum of the left side elements would be s of I minus 0. Why minus 0? To convert it into integer. So this is added, and now we need to subtract the right side element. So right side element would be n minus I minus 1 and minus 0 to convert it into integer. So that's all. After this loop completes, we will check if our sum is equal to 0 or not. If it is, then we will increment our answer. And like this, we will keep calculating our answer and return our answer at the end. So this is one logic which would work. Now another simple logic would be, if you see here, we have the constraints and the constraints are very low. It is still 10 to the power 4. So 10 to the power 4 means 10,000, right? So we have numbers from only 1 to 10,000. And now if you see the even slots here, because the odd range won't make the symmetric integers, because we want 2 into n digits, so odd digits won't make it. So from 1 to 100 we can split it 100 to 1000 and then 1000 to 10,000. Now we see between 100 to 1000, where 1000 is not included, it will form odd numbers. So we don't want this range also. So we are left with two range, 1 to 100 and 1000 to 10,000. Now we can check in 1 to 100. So when you observe in 1 to 100, whatever numbers are symmetric, they are 2-digit numbers. So 2-digit numbers are symmetric when both of the numbers are equal. So it will be 11, 22, 33 and so on till 99. Hence here we can write the condition that if my number is less than 100 and number is divisible by 11, then I can mark this number as symmetric integer. So my answer would be answer plus 1. Now we go to the second loop, which is 1000 to 10,000. Now if my number is less than greater than 1000 and number is less than 10,000, then we will now extract the left and the right number. We will minimize this. Yeah. So we will extract the left and the right number here. The left one would be, now in case this number can be something like, suppose 1203. So the left part would be 12 and the right part would be 03. So to extract the left part, first what we would do, we can simply divide it. We divide this number by 1000, then calculate the remainder also, and this remainder would come out to be 203. Now from this, for this we will divide it by 100. So from the first one, this one, we got 1. From second one we got a 2. So 1 plus 2 would give us 3 in this case. Now we go to the next part, which is 1203. Now 1203, we want 03 from this side. So what we will do? We will do 1203 the remainder of it with 100 now, because if we take with 100 and divide by 10, and we would add our 1203 remainder with 10, so it would give us the first one. This one would give us 03, and 03 divided by 10 would give us simply 0. So it will be 0 plus 1203 modulus 10, that would give us 3, because the remainder of divide by 10 would be 3. So this gives us 3. Now we have got this left sum, we have got this right sum. We will check if left sum is equal to right sum. If it is, then we will increment our answer. So in this case, what we need to do, I will just copy paste this thing. So this is our first step, and after modulus we are also dividing by 100. So instead of 1203, you can put your num here. And then this is our left. Let's calculate the right one. So right is this one. So whole this is the right part, and just replace num. Now if left equal to right, then we would increment our answer. So these are the two implementations which can work here, and hence we can do by any one of them, while this one would be the better one, because here we are simply working with the integers, we are not converting anything to string, and that would also work. Now let's see the solution one, in which we are converting to string. So we are going from low to high, we are converting the number to the string. Every number from low to high, we are calculating its length. We are checking if this is divisible by 2, which means the digits are even. If digits are even, we will proceed. We will keep sum 0. We will go from 0 to half of the length and add the left sum, subtract the right sum. If sum becomes 0, increment the answer and return the answer. Now going to solution 2, which we discussed now. We will see in I less than 100 that if it is divisible by 11, because all the series we talked about were divisible by 11, as you see, 11, 22, 33, 99, and then we would increment the answer because this is symmetric integer. Now if it is greater than 1000 or less than 10,000, which we took from example 1203 and checked, now my left would be this and right would be this, as explained above with the help of the example, this one, this whole example. So after checking this, if my left becomes equal to right, I would increment the answer and simply return the answer. So this is because our constraints were less, so we can directly check it. If constraints are high, then you can go for this solution. There might be other solutions as well because a problem has multiple solutions. These are the two approaches which I implemented and hence I discussed. So I hope the solution is clear now. Thanks for watching.